Hey everyone, today I'm going to show you a shortcut for solving differentiation problems using your scientific calculator. But then, here is the thing you need to understand. Your calculator cannot give you an algebraic answer. For example, if you are asked to differentiate 2x squared, it won't tell you the answer is equal to 4x. What the calculator is going to do is that it's going to differentiate this function and obtain the differentiated value, which is also a function, and then we'll evaluate this function at a specific point, which must be part of the domain. If it is not part of the domain, it is going to make the function undefined, and so you are going to have math error on the scientific calculator. And so in this case, let's say I'm going to pick a point 2. The calculator is going to evaluate this differentiated function at the point 2. And so it's going to be what? 4 times 2. And the answer is going to be what? 8. And so in multiple choice questions, we could have something like this. Option A is 3x. Option B is 5x. Option C is 4x. So what we are going to do is that we are going to plug this value 2 into these options. The one that is going to give us 8 becomes the correct option. And so as you can see, option C is the correct option. And so when we pick our scientific calculator, you realize that you're having the y dx of a function being evaluated at a specific point. And so that is how the calculator works. Another thing you should take note of is that anytime you want to differentiate functions using the scientific calculator, you should ensure that your calculator's mode is changed to radians. This is because we don't want to be having answers in degrees when we differentiate functions such as trig functions. And so to do this, we are going to say shift mode, and then option 4 is the radian mode. That is it. So with this, we can start differentiating. So now we want to start with question 1. You have to find y prime if y equals x to the power x. And so we are going to say shift the y dx, and we are going to plug in the function into this bracket. So we are going to have alpha x to the power alpha x, and then we are going to evaluate at a point 2, which must be part of the domain. And so we press equal to sign, and the answer should be 6.7725. 6.7725. So what this means is that if you are to plug in 2 into these functions, the correct option is going to give us a value of 6.7725. And so we are going to do that with a calculator. Remember to be fast. And so the first thing to do is that we are going to store the value 2 as the variable x. So that is it. Now we are going to test the options. We're going to have alpha x to the power alpha x, and then times 1 plus ln of x. Then we close it. And so the answer is exact as 6.7725. So option A is the correct answer. Question 2. We are to find the derivative of f of x, which equals 3 minus sine h of x all over 6 plus sine h of x. These are hyperfunctions. So this is what we are going to do. Now we are going to have shift dy dx. Then we bring our bracket, division. Then we are going to have 3 minus sine h. And so we are going to press this hyper button. Then we are going to choose sine h, which is the first option, sine h of x. And so we are going to say alpha x, close it, and close the entire bracket. And then we come down. We are going to have 6 plus sine, sine h of x, which is hyperfunctions. We are going to have option 1. Then alpha x, we close it and close the entire functions and evaluate it at a specific point, which must be part of the domain. Let's still pick 2. So anytime you pick the point and you enter and it is a max error, then you should just change the point. It means that it is not part of the domain. So at this point, we are having negative 0.365, negative 0.3653 as our answer. And so we are going to test these options. Remember, we have stored x as 2, and so in this case, it still works. So we are going to have the first option to be evaluated as hyper alpha x squared because of d square. Then we are going to have plus hyper, the cosh is the second option, of alpha x. We close it, then we come down. Then we're having bracket open 6 plus hyper sine h of x. So we are going to have alpha x, then we close it, and these all squared. Sorry, let me delete this. And these all squared. Then we press the equal to sign. We are having 0.1825, which is not the correct answer. And so option C is similar to option A with just a minus. So we are going to commit some changes to save time. So we make it minus and then press enter. So option A and option C are not the correct options. So we start with option B. So we are going to have negative 9 hyper cosh, which is the second option, alpha x over 6 plus hyper of alpha x. We close it, all squared. Excellent. And so option B is the correct answer. Question 3. Given f of x equals ln bracket open x to the power 4 times sine of x, find y prime. So you are going to have dy dx, dy dx of ln alpha x to the power 4 times sine of alpha x. So we close the sine function and close the ln function, and so that is it. And so we are going to have the specific point to be 2. Still, it's going to be 2. You can change it, but it must be part of the domain. We press on equal to, and the answer is 1.54. 1.54. And so we are still going to evaluate these options at the point 2, since we have used 2 as a specific point. So testing option A, we are going to have 4 on alpha x minus cot x, and that is equal to 1 on tan x. 1 on tan alpha x. Then we evaluate it. The answer is 2.45, which is not 1.54. And so option A is similar to option C. So we are going to commit some changes. This time we make it plus and evaluate it. The answer is 1.54. So option C is the correct option for question 3. Find f prime of the variable theta if f prime of theta equals e to the power sine theta. Now, there is no theta on the scientific calculator, so you're going to use x as theta. So let's try to differentiate this function. We're going to have dy dx of e alpha e to the power sine alpha x. I'm still going to evaluate it at a point 2. And the answer is negative 1.03. So we are going to test the options. Testing option A, we are going to have cos alpha x, then we close it, times alpha e to the power sine alpha x, and the answer is negative 1.03. So option A is the correct answer. Question 5 says that we are to find the differential of f of x, which equals x squared e to the power x at the point x equals 1. So we are going to pick our scientific calculator and then say dy dx of this function alpha x squared times alpha e to the power alpha x, and we are asked to differentiate it at a point x equals 1. So we are going to choose 1, sorry, and the answer is 8.154. 8.154. So now let's test the options. What's the value of e? E is equal to 2.718. Then what's the value of 2 times e? 5.436. Then finally, what's the value of 3e? That is 8.154. And so option C is the correct answer. Question 6. Find the differential of this function. So we are going to differentiate it using the scientific calculator. So dy dx of alpha x squared times tan of x. Then we close it and evaluate at a point, let's see, 2. Remember, we have still stored x as 2. And the answer is 14.35. So testing the options, we are going to have alpha x times alpha x times sec squared x. Now sec is actually 1 over cos. So you're going to have times 1 over cos alpha x, and this is squared. Then plus 2 tan of x. Then we close the entire function. Then evaluate it at 2. We are having 14.35. And so option A is the correct answer. Question 7 says that we are to find the derivative of this function. So we are going to say dy dx of the function alpha x squared, the hyperfunction 2 alpha x, close it, and we will evaluate it at the point 2. And the answer is 10.3191. 10.3191. So we are going to test the options. So with the first option, we are having alpha x multiplying the hyperfunction of 2 alpha x, we close it, minus alpha x on root of 1 plus 4 alpha x squared. Then we close it. The answer is 3.21, which is now equal to 10.3191. Option A and option B are similar, so we are going to commit some changes. So this time around we have 2 times x, and then we have a plus instead of minus. And the answer is 10.3191. So option B is the correct answer. Question 8. We are to find the differential of this function. So we are going to have dy dx of the function, which is a hyperfunction. So we are going to choose option 6. Root of alpha x. Then we close it and evaluate it at the point 2. As we can see, it sees math error. It means 2 is not part of the domain. So we are going to choose another option. Let's see, 0.5. Then the answer is 1.414. 1.414. So we are going to test these options. So this time around, our x is now 0.5. So we are going to store 0.5 as s. So now x is now 0.5. So we can start testing the options. Option A, we are going to have 2 times alpha x multiplying hyperfunction. Option 4, 2 alpha x close it. Then we have plus alpha x on root of 1 plus 4 alpha x squared. Then we close the entire function. We're having 1.234, which is now 1.414. So we test the second option, option B. We are having 1 over 1 minus alpha x squared, which is 1.333, and that is not the correct answer. We are going to check square root of 2 times alpha x on 1 minus alpha x squared, which is 1.154, which is not the correct answer. Then we are going to check the final option, which is 1 on 2 root of alpha x times 1 minus alpha x, close it, and that is 1.414. And so option D is the correct answer. The derivative of this function is this answer. We've already solved this question before, and the answer was -9. I mean this answer. So it is true. Now, given y to be equal to this function, compute y prime. So you're going to pick a scientific calculator. Then you have dy dx of 4 to the power alpha x, then plus 5 log to the base 9 of x alpha x, and we will evaluate it at a point 2. And the answer is 23.31. So now we are going to store 2 as x and start evaluating. And so we are going to have 4 alpha x ln 4 minus 9 on alpha x ln 5. 8.29. Option A and option C are similar. So we want to change the minus sign to plus. That is 13. So option A and C are not the correct answer. So with option B, we are going to have 4 to the power alpha x ln 4 plus 5 on alpha x ln 9. Then we close it. And the answer is 23.31. So option B is the correct answer.